Hello everyone. Today I'm going to introduce a composting system. What is compost? Compost is aerobic biological decomposition of organic matter to produce compost, that is a soil amendment. So composting as aerobic, this means that we have to provide air or oxygen for microorganisms to work and to disintegrate the organic matter into a more stable product, that is compost. Again, compost has many benefits to soils and has been actually produced from different organic matter, including food waste, manure, field residues, and any other organic matter that is safe for soils as amendment. So aerobic biological decomposition, or the composting in this case, is a natural process that is enhanced and accelerated by mixing the organic waste with other ingredients. This ingredient actually can be, as I mentioned, maybe food waste with some straws or manure with a straw. So basically, we have to have some kind of recipe for successful composting. And this ingredient or this recipe prescribed the manner to optimum that provide the essential nutrients for microorganisms. To have successful composting, there are several requirements, and among them actually the source of energy and the nutrients, and frequently, as we mentioned before, for anaerobic digestion, we have to have CN ratio, or carbon to nitrogen, and this may be ranging from 25 to 40 to 1, of course, means that we have to have 20% or 40% in this range of carbon to 1% of nitrogen, or in other words, the CN ratio is 25 to 40 to 1, of course. This is basically the numerator to the denominator. This means that we have 25%, this in this range, basically 25 to 40 to 1. Okay. And of course, we have to have moisture content in the material. Basically, we have to have sufficient moisture from 40% to 60% wet basis, which means that we have to have proper moisture content. Otherwise, if we have very dry material below 40%, we may not have actually enough moisture content for microorganism to work. And if we have more than 60%, we will have some issue, because basically at the end we have to provide some kind of porosity in the material. So if we have over 60%, which means that we have a lot of moisture around the particles, which limits the amount of air passes through the bulk of the composting pile, for example. So in this case, behind 60% or larger than 60%, we will have some kind of anaerobic conditions because of the limitation of the porosity, or the limitation of the pore space that can guarantee the air can go through them. Okay. Of course, we will have sufficient oxygen. Again, this is maybe related to the previous point also, that we have to have enough porosity in the material so that the air can go through the particles and provide the essential oxygen for microorganism to work. Again, the pH also in the range from 6 to 8. Okay, so with that, I'm going actually to also to introduce the composting methods, and the first system is the windrow, and the windrow here is big piles, very long, arranged in very long rows, and these piles actually can hold again one or two or more material, maybe manure with straw, or food waste with manure. It depends on the recipe that you are going to work with. And this, of course, is the the windrows can go actually. The height may be about 4 to 6 feet, and the width is 6 to 10 feet. And maybe if you have more than one pile, maybe you have to also have space, at least maybe 6 feet between the piles, because basically you need to have enough space for equipment to come to turn the piles. And the turning means that we have to mix the material to have this kind of, for example, in this area here, we have this turner, special equipment for turning the pile, and maybe also it can also be turned by front loader or a tractor or something. So the idea here is just to give some air through the piles over time. This maybe can also do the turning maybe from 2 days to 10 days, depending on basically in the weather conditions, depending on the size of the pile, depending on also the recipe, because basically if you have a lot of material in the pile that is actually bulk or has limited air space or porosity, you have to turn more, and so on and so forth. Okay, so again, this is maybe simple enough system, but it need some kind of equipment to turn, or also it may actually need more space, because basically if you have only 4 or 6 feet height of the pile, this means that you will have a big footprint on this systems. Okay, the next system is the static pile system, and this static pile system is a big also pile, maybe similar to the windrow, except that the material actually is put on perforated plastic pipe or tubing. Through these pipes, we blow some air with some kind of blower, and then maybe just basically this under section probably in this system, because basically this is a blower or fan. You can actually blow the air or suck the air out, depending on the directions that you are designing. And this forced air pile may not be actually necessary with a small composting piles, because basically if you have a higher porosity, you may not actually need to have forced air. So basically if you have a small pile, you may be actually just put the pipe, and there is no need for electricity to blow air through the pile. Okay, the height of the pile may be from 8 to 15 feet, and again, the width is maybe twice the height. And what is happening here, after you put the material over the perforated pipe, you need to also to cover the pile with some kind of mature or screened compost to make sure that it's insulated from the outside, and the top part will be converted to compost. Basically, this is if you have a layer maybe 4 or 5 inch of compost, this basically as insulation from being actually exposing the top surface to just the ambient, and it can get dry very quick, and also it will not be composted. Just to put this kind of insulation to make sure that the whole pile is converted to compost. The outlet of the air, you may actually also, if you suck air here, you may actually also take the air out from this pile and pass it through absorbent to reduce the odor to the ambient, basically here. This is under this pile, in this case it will be under vacuum, basically. Again, this is maybe a system maybe also costly because of the blower, but it's still simple enough actually compared with the windrow, because you don't have to have big equipment. But the drawback here is that you need to provide source of electricity that you can get from solar energy or some other application. or some other sources. Okay, the last system is the infisels method. This is basically a reactor. You put the material in from the top, for example, and then you blow air through piping, through the bile, basically the bile inside this kind of container, inside this fizzles, and then you blow air through the bulk of the composting material and the outlet in order to come out here. On the top, for example, this also still you may put some kind of filter or similar system to absorb the odor from being actually emitted to the atmosphere. Again, it may need actually more sophisticated systems. This may be expensive. It's not really common per se in the commercial scale yet, but still actually good systems that you can control the condition, you can control the temperature, and you can control how much air you need to apply to the material. You can also apply some kind of heat exchanger to recover some of the heat that is produced during the combusting. Again, either turning for the windrow or for blowing air through the static bile or through the infisels. The most important part is that the temperature should be kept at maybe 170 Fahrenheit or about maybe 75 degrees. Basically, above this, it can actually reduce the amount, the activity of the microorganisms, and basically the temperature is the main controlling parameters that affect the number of turning or the air flow rate through the static bile or through the infisels systems. With that, I think this is basically just some information about the systems. I hope this beneficial, and see you next time. Thank you. Bye-bye.